Okay, hello everyone. Welcome back to Math 0314, College Algebra. So last week we were talking about expressions and how expressions are these groups of numbers put together with operations that have a value represented somewhere behind them. So today what I want to go over is equations, and it's not going to be all that long, honestly. I want to go over the types of equations and then some special cases that you might see with these equations. So let's just start with an equation real quick. Oh, that's a terrible place. There we go. So 6 times 5t, 5t minus 9 equals negative 31 times 9 minus t. Okay, so there's our equation. So if you look, this equation is actually made up of two parts. Let me separate them real quick for us. So we have this part right here and this part right here. Both of these are expressions. So 6 times 5t minus 9 is just its own expression. In the same way, negative 31 times 9 minus t is another expression. And what is happening here is this equal sign right here is comparing the two to each other. What it's saying is, I want these to be equal. Exactly equal at that. So, perfectly balanced. And there's some value for t that we could plug in for t to make this thing balanced. You know, some numbers that we plug in for t won't make it balanced, but there's one that will. So let's see if we can figure out what this would be. To find the value for t, or whatever variable you have, whether it be x, y, z, whatever, that will make this thing balance, what we need to do is solve this equation. And solve means that we need to get the variable by itself. So there's a few things we need to do that. First of all, these are, again, expressions. And expressions, like we were doing last time, can be simplified. So we'll go ahead and simplify these expressions by using our order of operations. So I'm just going to look at this one by itself for right now. We have 6 times 5t minus 9. So going through our order of operations, I've got parentheses, but I can't do anything inside of them. I don't have any exponents. I do have multiplication, though. I've got 6 times 5t minus 9, and I can distribute this 6 into this set of parentheses. So let's see, what do I get once I distribute those? Okay, so 6 times 5t is going to give us 30t. Okay, and then 6 times negative 9 is going to give me negative 54. All right. Same on the other side. Over here I've got negative 31 times 9 minus t, so I can also distribute that into these parentheses. So on this side, if I distribute negative 31 into 9, 9 times negative 31 is negative 279. Then negative 31 times this negative t, negative times negative is a positive, I get positive 31t. Okay. So there's our new equation with our new expressions. Now that we've gotten to here, we have to ask ourselves, can we simplify these any farther? So let's look at this one. 30t minus 45. Well, again, can we multiply? No. Can we divide? No. Can we add and subtract? Well, we could if these were like terms, but this one's a t and this one's a constant, so yeah, we can't do anything there. Same on this side, too. We can't do anything else in our order of operations to simplify it, so that's as far as we can go with that. Now we can actually start using the equals part, the equation part of this equation. So again, what we want to do here is get t by itself. So what we can do is we can say, all right, well, I want t on one side. I have t on both sides here. I want it on one side. So I'm gonna take t from one of these sides and put it over on the other one. And here's how you do that. Oh, come on. Okay. The t that is on this side, I'm just going to do this with a marker. The t that is on this side, I can subtract let's make it a little bit neater. Negative 30t, and that will cancel that. Essentially, because this is positive 30t and this is negative 30t, they cancel. However, remember that this equal sign says, wait, I need to be balanced. So I also have to do it to this side, negative 30t. So that cancels on this side, leaving me with just the negative 54. And then on this side, I still have that negative 279. Nothing's happened to it. But here I've got 31t minus 30t, so that leaves me with a single t. Okay. So similar to how I want t on one side by itself, I want my constants one side by themselves. So I want to do kind of the same thing and add negative 279 to this side to get that t by itself. Why am I full of adds? Okay. So plus 279, because again, this is negative 279. I need to do the opposite. So plus 279. Oops. And do that to both sides. So that cancels here, leaving me with just t on this side. And on this side, it's going to combine with this negative 54. So my new equation looks like this. 225, oops, which is negative 54 plus 279, equals t. And right there is my solution. That is the one value for t that we can use in here to make this thing balance out, so that both of these have the same value. No other number will plug into this equation for t to give us the same value on both sides. This is what we call a condition. And in fact, the name of this type of equation is a conditional equation. Okay? So if you solve an equation and you get something like x equals whatever, or in this case t equals 225, that is a condition. It is the condition that makes this thing work. So, what else do we have for our equations? What other types of equations do we have? Well, let's go ahead and take a look. So, new equation. 6w plus 5 equals 6 times W plus 2 minus 7. Whoops, where'd that come from? And again, this equation is made up of two parts, two different expressions that are equal to each other. So once more, in solving an equation like this, what we're looking for is the number that we can plug in for W to make this thing balance out so that both of these have the exact same value. In other words, we want this value to be equal to this value. Exactly the same. Okay, well again, first thing we need to do is make sure that our expressions are simplified. So 6W plus 5, let's see. Working through our order of operations, do we have any parentheses? No. Exponents? No. Can we multiply? No. Divide? No. Add and subtract? No for both. So this one is already as simple as it can get. We can't simplify this side any farther. This side. Actually, yeah, we can do something. Working through our order of operations, the first thing we can do is multiply this 6 into W plus 2, just like we did with these. We're distributing it. So, when we distribute that in, we are going to get, well, same thing on this side, 6W plus 5 doesn't change, like I said. And then on this side, 6 times W plus 2, 6 times W is 6W. Then 6 times 2 is 12, and then we drop down that negative 7. Okay, so is there anything else that we can do to simplify this? Yeah, we've done our multiplication, there's no division, but we do have addition and subtraction, so we can combine these like terms right here, 12 and negative 7. So if we go ahead and combine those, this side will still be 6W plus 5, and the other side will be 6W, then let's see, 12 minus 7 equals 5. Interesting. So we have the same thing on each side of our equal signs. Now remember, the goal here in solving this is to have the same value on each side of the equal sign. And essentially, we already have that. Well, let's go ahead and try to solve it anyway. So, let's do W's to the left side, this side over here. So I'm going to need to subtract that 5. And, of course, I need to do that to both sides. Okay. So let's see, that means that these will cancel, and these will also cancel. So, we are left with 6W on both sides. Again, still the same thing. Alright. Keep working on it. Keep solving. So 6W and 6W, I really want to get W to one side, so I need to take this 6W and bring it over here. Well, the way I do that is I subtract 6W from this side and subtract it from this side as well. So I think you can probably see what's going to happen here at this point. 6W from this side and 6W from this side. Well, what does that leave us with? That leaves us with 0 equals 0. 6W minus 6W obviously is 0. 6W minus 6W is, again, 0. So at a certain point, the entire equation is just balanced the entire way through, and everything cancels everything else out. So what does that mean? Well, what this means is the W doesn't really matter. we can plug anything in for w, and it will balance out. It'll make this equation work. It'll make it true, no matter what we put in there. Okay? So, this is what we call an identity. And in an identity, the answer is that our variable could be all real numbers. So, in this case, w equals all real numbers. Oops. So there's our answer. So in a conditional equation, we solve it and we get some kind of condition that makes this thing true. So in this case, t has to equal 255 for this thing. I'm sorry, 225 for this thing to balance out and be correct. This one, it doesn't matter what we plug in for w. Whatever we plug in there, it's going to always come out to be equal. So it's an identity. And there is a third type of equation. So let's go ahead and try that one. So let's take a look at this one. We have 2 times x minus 1 plus 3 equals 3x minus 1 times x plus 4. So yet again, we have an equation here that is made up of 2 separate expressions. So we want to simplify those expressions if we can, and then afterward we can move things around to solve. So let's see what we can do about these expressions. First of all, this one. Again, no exponents. The parentheses, we can't do anything inside of them, but we can multiply something. We can multiply 2 into this set of parentheses just like we did with this one and with this one. So I'll go ahead and do that. So 2 times x minus 1 is going to give us 2x minus 2. And then that plus 3 drops down. Whoops. There we go. Almost lost it. Okay. Other side, we can also multiply. This negative 1 here can multiply into this set of parentheses, just like we did with the 2. So 3x drops down. And then negative 1 times x is negative 1x, or we can just put negative x. And then negative 1 times positive 4 is negative 4. So there's our 2 new expressions. We still need to ask ourselves, can we simplify any further? And yeah, absolutely we can. This side, we have like terms, negative 2 and 3. So if we combine them, we now have 2x. Negative 2 plus 3 is positive 1. Other side, again, we have like terms, 3x and negative x. So 3x minus another x, that's going to leave us with 2 x's. And then the minus 4 drops down. And here we have something very interesting. This says 2x plus 1 is the same thing as 2x minus 4. Well, that doesn't make a whole lot of sense. We can't add something, we can't add 1 to something and have it be the same thing as subtracting 4 from that same thing. Really does not make any kind of sense. But again, we can keep trying to solve this. So I'll move this 1 to this other side, So actually I'm going to put it closer up. So minus 1, and then minus 1. So these cancel. It's gone. So now we just have 2x by itself on the side, and 2x minus 5. Again, that does not make any kind of sense. 2x is not the same thing as 2x minus 5. We're subtracting 5 and it's still the same? Doesn't make any sense to me. Let's keep going though. So let's move this 2x to this other side. So we will need to subtract 2x from this side and this side. So minus 2x and minus 2x. Again, it cancels on this side. Whoops, let's try that again. Cancels on this side. And we brought it to this side over here, but these are also going to cancel, leaving us with 0. So our new equation says 0 equals negative 5. Well, that absolutely does not make any kind of sense. 0 cannot be equal to negative 5. They are not the same thing. So what's going on here? Well, the answer is that nothing will make this equation work. These two expressions just cannot ever become equal to each other. And we could see that in the signs back here. You know, like I said, 2x plus 1 is the same thing as 2x minus 4. We can't have adding 1 be the same as subtracting 4. Okay? So this is called a conditional equation. Oh, sorry, not a conditional, a contradiction. Contradiction. And its answer says, doesn't matter what you put in for x, it's never going to work. So x equals an empty set, which I actually don't know if I have that key on my keyboard because I don't have an expanded one. Nope. So I'm just going to say no solution. So there's our answer for that equation. So again, we have three types of equations. Conditional equations, where we solve it and we get a nice little answer for our variable. That means that if we plug this number in for our variable up here, it will make this thing balance out. These will have the same values. Identities, where it doesn't matter what we put in for our variable, it'll always work. So we could put in whatever number we want in there. It just has to be a real number. Oh, I forgot to turn my phone off. And so that's an identity. Contradictions, you can't ever make these things balance out. No matter what you plug in for x, they are never going to balance out. And so there's no solutions. Oh my god, I gotta turn that thing off. Okay, sorry about that. So, we will have a quiz on Friday, by the way, and these are going to be on there. There's one more thing I want to show you before we go today, but remember, conditional equations, identities, and contradictions, they are going to be on that quiz. So let me just get rid of everything here. What was that I was using to... I don't remember. Oh, Element Eraser, that's what it was. Go away, dot. Okay. It's the next thing I want to show you. we mentioned absolute values last time. I want to go over it again real quick. So if we have an absolute value of, say, 2, absolute values take a number and disregard their sign. So they only treat them as being a distance. Remember, distance isn't positive or negative. Distance is just distance. So, like, I'm not negative 6'7". I'm not positive 6'7". I am 6'7" tall. Okay, so that's what these absolute values do, is they disregard that sign and treat the number as a distance instead. So the absolute value of 2 is just its value, 2. The absolute value of negative 2 as well equals 2. It's just its value, not the positive, not the negative, just the value. Okay? So something interesting happens when we have something like this. Absolute value of x equals 2. Okay, so what does this mean? Well, we know that x has to be some kind of 2 to get this absolute value 2 out. We just don't know what it is. We don't know if this is a negative 2 in here, because of course we could put a negative 2 and that would work. We don't know if it's a positive 2, because 2 would also work. All we know is that it's x. So here, what we would have to say is, well, x could be 2 different things. X could be equal to 2. There could be a 2 in the inside there, or it could be negative 2. So there's actually 2 answers to this. Again, x could be 2 or x could be negative 2. Because, again, we don't know what this is inside of here that's giving us this 2 out here. It could be 2. It could be negative 2. Either one of those would work. All we know is that it is x. So let's take a look at this example that I have here. Absolute value of 2x plus 3 equals 5. Okay. So we basically have the same problem going on here. We don't know what 2x plus 3 is. Again, it's an expression, and we know expressions have a value behind them, but we don't know what that really is. What we do know is that when we take the absolute value of it, it gives us 5 out. So this thing has to come out to be either a positive 5 or a negative 5. Just like this x up here could have been a 2 or a negative 2, this whole thing in here, in order to get this number on the outside, has to come out to be either 5 or negative 5. So what we do is we say, all right, we don't know what it is. We don't know if it's 5 or negative 5, but we can split it up. 2x plus 3 could be 5. However, 2x plus 3 could also be negative 5. We don't know. That's what we're trying to figure out. Okay. So we can solve each of these 2 equations separately now and see what we get. So 2x plus 3 equals 5. Well, we need to get x by itself. So the first thing we're going to do is we are going to subtract that 3 from both sides. Okay. So this 3 will cancel with that one, and then here 5 minus 3 is 2. So our new equation is 2x equals 2. Okay, now we have 2x equals 2. We want to get rid of this 2. Now we can't just say minus 2, because that x is attached to it. That x is part of 2x. So we need to separate the 2 from x. So the way we do that is we say, all right, well, what's really happening here is this is 2 times x. So the opposite of that, in order to cancel that out, would be to divide by 2. So we divide by 2 on both sides. Okay. So that will separate the 2 from that x, leaving us with just the x left, which is good. And then our 2 divided by 2, well, anything divided by itself is 1. So x could be 1. But we can't stop there. Remember, we need to solve this one as well. Basically the same steps, though. Subtract 3 from both sides. So subtract 3 from this side, it cancels. Subtract 3 from this side, we get negative 8. So 2x equals negative 8. And then divide by 2 on both sides. So divide by 2 on the 2x side, we just get x. Divide by 2 on the negative 8 side. Negative 8 divided by 2 is negative 4. So we actually end up getting 2 answers. X could be 1, or it could be negative 4. And so there's our answer for this one. Now, like I said, there's 3 types of equations. There's conditional, identity, and contradiction. So which is this one? Well, remember that contradiction doesn't have any answers at all. An identity has an infinite amount of answers to it, and a conditional equation has some condition that makes the original thing true, which is what this is. This is a conditional. So we call this a conditional, again, because there are conditions that make this true. So the condition here is that we could plug in 1 here for x. So 2 times 1 is 2, plus 3 is 5. Absolute value of 5 is 5. That works. Or we could plug in negative 4. 2 times negative 4 is negative 8. Negative 8 plus 3 is negative 5. Absolute value of negative 5 is 5. So there are 2 conditions that make this correct. That's fine. We can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, however many conditions, and it'll still be a conditional equation. The difference between this and an identity equation, though, is that an identity has an infinite amount of answers, infinite amount of numbers you could plug in for that variable and get this thing to work. Conditional, there's a finite amount of conditions, finite amount of answers. Okay. So I think that will do it for today. Again, quiz on Friday. So that quiz is going to have y'all simplify expressions. It's going to have you solve equations and hopefully be able to tell me what kind of equation it is. And there's going to be some questions about what kind of numbers we have. So, like, know what real numbers are, know what non-real numbers are, know what rational numbers are, know what irrational numbers are, know what integers are. And so those are the things that will be on the quiz on Friday. And as long as you can do all that stuff, you'll be golden. All right, but again, that's it for today. I will see y'all on Friday, and I hope you have a great day.